Good morning. Next is the orientation effects of substituents. So we are discussing the properties or reactions of benzene. Next is the orientation effects of substituents. Orientation effects of substituents. Okay. First one is ortho-para directing groups. Ortho-para directing groups. What do you mean by ortho-para directing groups? So the main heading is orientation effects of substituents. What do you mean by substituent? Suppose this is our benzene. In benzene, if a hydrogen atom is replaced by a NH2 group, okay, this is a substituent. NH2 group is a substituent. Okay, another substituent is, look at here, here is our benzene. A hydrogen atom is replaced by OH. This is another substituent. Or another one is, look at here, here it is replaced by CH3. So these are all called substituent. Okay, now what is that? Orientation effects of substituents. What do you mean by orientation effect of substituents? Out of that, the first heading is, what is that? Ortho-para directing groups. Or what do you mean by ortho-para directing groups? So first let us discuss these two compounds. One is aniline and the other one is phenol. What is this compound? Aniline, and this one is phenol. Okay. Now look at here. What is the speciality of this substituent or when you consider aniline and phenol? Look at here. Here the aniline, that means in aniline nitrogen is attached to the ring. Which atom is attached to the ring? Nitrogen is attached to the ring, and the atom which is attached to the ring, this nitrogen is having a lone pair electron. It is having a lone pair electron. Similarly here also the oxygen is attached to the ring, and of course the oxygen is having lone pair electrons. So these type of groups, in such groups we can see that the atom which is attached to the ring is having unshared pair of electrons. So when groups attached to the benzene ring, or the atom which is attached to the benzene ring is having unshared pair of electrons, are called activating groups. This NH2 group is activating group, OH group is activating group. So that means NH2, OH, OR, etc. are called activating groups. Why they are called, or what do you mean by activating groups? Activating groups means the atom or the group which is attached to the benzene ring is having unshared pair of electrons. Such groups are called activating groups. Now why they are called activating groups? Look at it here. The actual structure of benzene, instead of a ring I am showing the exact bonds. Okay. Now you can see that due to plus R effect or plus M effect. What do you mean by plus R effect or plus M effect? You can see that this unshared pair of electron is donating electrons towards the ring. Unshared pair of electron is donating. This electron is delocalized into the ring. That means this pair of electron is first it is moving to here. Then that time what will happen? This bond, this pi electron, this will be shifted to this carbon. Okay, this is what is called plus R effect or plus M effect. The delocalization of unshared pair of electron into the ring, then what we get, the next resonance structure will be like this. Look at it here. Okay, here it is double bond NH2. Of course, since the electron is moving from nitrogen, nitrogen is getting a positive charge, and this pair of electron is moving to this carbon. Carbon is getting a pair of electron and a negative charge, and here it is like this. Now, in the next stage, what is happening? You can see that this pair of electron is moving between these two carbon, and that time this pi electron will be moved to this carbon. We get the next resonance structure like this. Here it is double bond NH2, and here is positive charge. Since this pair of electron is moving here, is a double bond. This pair of electron is moving to this carbon. This carbon is getting a pair of electron and a negative charge. Of course, this double bond is here. And in the next structure, what is happening? This electron will be moved between these two carbon. Then this pi electron will be moved to this carbon. What we get? We get the next structure like this. Double bond NH2, and here it is positive charge. Here is this bond, and since this electron is moving, here is double bond, and here this carbon is getting a pair of electron and a negative charge. And finally, what is happening? This will be shifted to here, and this bond will go back. Okay, so what is happening? We get what is that? Here is double bond, here it will become double bond, and here it will become NH2. Okay, now in the next one, what will happen? Again it will come here, this will go this direction, opposite direction it will continue. Now by resonance, we can see that by the delocalization of the unshaded pair of electron and the pi electrons, we can see that this is ortho position, this is para position, and this one is again ortho position. So ortho, this is meta, and this is para, this is again meta, this is ortho. Okay, by resonance you can see that, or by plus R effect or plus M effect of NH2 group, we can see that this position is ortho position, and this position is para position. Again, this position is ortho position. The ortho and para positions are negatively charged. They are negatively charged. Therefore, what type of reaction will be given by benzene and its derivative? They will give electrophilic substitution reaction. They will usually give electrophilic substitution reaction. Since the ortho and para positions are negatively charged, we can see that this group, if NH2 group is present on the ring, the incoming electrophile means, what do you mean by electrophile? Electrophile is a negatively charged species. Positively charged species, as we already discussed. Which are the electrophiles we discussed? First, nitration, NO2 plus, sulfonation, SO3H plus, bromination, Br+. These are all electrophile. This electrophile will come and attack at the ortho and para positions. That is why these are called ortho para directing group. Which are ortho para directing group? Example is NH2 group is ortho para directing. Or generally, what is ortho para directing group? Groups which is having unshaded pair of electrons. Okay, that means the atom which is attached to the ring must have unshaded pair of electron. Are called activating group. Why they are called activating group? Because of the unshaded pair of electron. This pair of electron will be pushed towards the ring, and we can see that because of plus R effect or plus M effect, the ortho and para positions are negatively charged. Therefore, the incoming electrophile positively charged species will come and attack at the ortho or para positions. So this is called activating group, or such groups are ortho para directing. Okay, similarly, if you take phenol, now let us take another example. Phenol. Okay, phenol, which group is present on phenol? OH group. So you can see that here again the same structure. Here it is phenol, OH. Oxygen is having unshaded pair of electron. This will be shifted to here. So what will happen? This pair of electron will be moved to here. So ortho position is having a pair of electron and a negative charge. The next moment this pair of electron will be shifted to here. Then what will happen? This pair of electron will be shifted to this position. Again, para position is having a pair of electron and negative charge, and it goes like this, and we can see that when OH group is attached to the benzene ring, again because of plus R effect or a plus M effect, we can see that the ortho and para positions are negatively charged. Therefore the incoming electrophile will attack at the ortho and para positions. Such groups are called activating group. They are called activating groups. Okay. If you want, I can complete this structure also. So what is the first structure? Again, you get the first resonance structure like this. Here it will become double bond, and of course here is positive charge. Here is a pair of electron and a negative charge. Here is the double bonds are like this. In the next step, what is this pair of electron will be shifted between these two carbon. This bond will be shifted to here. So we get the next resonance structure like this. Here is double bond, and here is a pair of electron and a negative charge. And here is double bond OH plus, and then the next step it will be shifted to here. This will come here, and we get the structure like this. Here it is double bond. Here is double bond. It's a pair of electron, and then a double bond OH and a positive charge. Next step, this will be shifted to here. This will go back. Okay. Then means here also you can see that the ortho and the para positions are negatively charged because of the plus R effect or plus M effect. Okay. Such groups are called activating groups. Okay, these are strongly activating group. These are called strongly activating group, and of course the activating groups are ortho para directive. Now let us consider a weakly activating group. Weakly activating group. Which are strongly activating groups? Examples, those group is having unshaded pair of electrons. That means NH2, OH, O, R, etc. These are strongly activating group. Now I am taking a weakly activating group. What do you mean by weakly activating group? Look at here. Again, what is these are also coming at the ortho para directing group. Okay. Now look at it here. Suppose here it is CH3 methyl group. Alkyl group. If alkyl group is present on the ring, okay, now you can see that carbon outer electron is 4. That 4 electrons are used for making there are 3 hydrogen bonds. So CH3 means what is that? CH. Total outer electron is 4. The 4 electrons are used for making 4 bonds. Therefore, this carbon does not have unshaded pair of electron. Carbon does not have unshaded pair of electron. It does not have lone pair electron because outer electron is 4. That 4 electrons are used to make 4 bonds. There is no unshaded pair of electron. But also this methyl group is weakly activating group. Why it is weakly activating group? We know that the alkyl group, these are having plus I effect. Here which effect? Plus I effect is there. Plus, what do you mean by plus I effect? Electron pushing effect. Electron pushing effect of alkyl group. What will happen? It will push the electron towards the ring. So gradually it will create when it push the electron towards this direction, this electron will move to this carbon. That means it can, because of plus I effect, it can create a negative charge at the ortho and para positions. So one reason why alkyl groups are weakly activating group. What do you mean by activating group? Activating group means which can create a negative charge on the ortho and para position on the ring. Such groups are called activating group. The groups which can create negative charge at the ortho or the para position, they are called activating group. Strongly activating group means they have an unshaded pair of electron. That electron will come into the ring and they can easily make negative charge on the ortho and para position. But methyl group, when there is a methyl group on the ring, methyl group does not have unshaded pair of electron. Then also it will act as an activating group. One reason, because of plus I effect, it can push the electron towards the ring and it can gradually create a negative charge on the ortho as well as para position. second effect is second reason for why alkyl group are activating group because of hyperconjugation. Because of hyperconjugation, it can create a negative charge at the ortho and para position. What do you mean by hyperconjugation? Look at it here. If I take benzene, okay, here it is. If I take benzene, you can see that here it is CH3. This is our methyl group. What do you mean by hyperconjugation? You can see that this bond breaks from hydrogen and it will be shifted to here. Then here it will become a double bond. That time what will happen? This bond will move to this carbon. So look at here what we get. The first structure will be like this. This we have CHH and here it is H plus, correct? And what is forming here? Here it is double bond and you can see that here it is ring. Okay. In this ring, since this bond is shifting to here is a double bond. This pi bond is moving to this carbon. This carbon is getting a pair of electron and a negative charge. Here is the other bonds are there. Correct? Now we can see that in the next structure, what is next structure? This will be shifted to here. So here you can see this is ortho position. Okay. Now you can see that this bond, when this electron is shifting here, this bond will be moved to this carbon. So we get the next structure like this. Here it is CHH and here it is H plus double bond. Here is our ring. Okay. Our ring is here and here is the double bond and this double bond is moving to this carbon. Here is a pair of electron and here is the double bond. And in the next step what is happening? This will be shifted to here and what will happen? This will move to here. Okay, so here also you can see that because of hyperconjugation, the ortho and para positions are negatively charged and hence the incoming electrophile will attack at the ortho and para positions. Now such groups which can direct the electrophile on the ortho and para positions, the groups which can direct the electrophile on the ortho and para position, they are called activating groups. There are two types of activating groups. One is a strongly activating group and the second one is a weakly activating group. Strongly activating groups means groups which have unshared pair of electron, and weakly activating group mainly alkyl groups. Alkyl groups are weakly activating group. Alkyl groups are activating group. Why they are acting as activating group? Because of plus side effect of alkyl group, and the second one is hyperconjugation effect. Because of these two effects, the alkyl group can create negative charge on the ortho and para positions of the ring. Therefore, they can also act as activating group. Okay, thank you. We continue in the next class.